So in part B, we need to find the first two non-zero terms in the Maclaurin series of this function. And well, first idea might be to somehow rearrange this, so maybe use the trig identity to rearrange cosine x squared into some other term, and then use the previous two Maclaurin series we found in part A to somehow combine it. But this question is really only worth 2 marks, so that would be quite a lot of work just for 2 marks. So usually when we have Maclaurin series, IB likes us to take the derivative or integrate a specific Maclaurin series, as if we for example take the derivative of this, we can simply take the derivative of this side, and those two will still be equal to each other. So what we can notice here is that this term is actually the derivative of one of the functions we have already found in part A. So if we take the derivative of sine squared x squared, well, this is going to be, we're going to have to use the chain rule here. So firstly, we need to take the derivative of the inside function. So I mean, for the outside function, and then we need to multiply with the derivative of the inside function. So that will be 2 times sine x squared. And then we need to multiply with the derivative of the inside function, which here the inside function is sine x squared. So the derivative of that is cosine x squared. But in cosine x squared, we also have an inside function, which is x squared. So we need to multiply with the derivative of the inside as well. So that's 2x. And then what we can do now is combine terms. This will be 4x sine x squared times cosine x squared. And what we notice here actually is that there's exactly what the question is looking for. So what we can simply do is take the derivative of its Maclaurin series as well, this specifically. So we can say that 4x sine x squared cosine x squared is equal to the derivative of x to the 4 minus x to the 8 over 3. And then obviously so on, but here we only need the first two terms. So this will be 4x cubed minus 8 over 3 x to the 7. And again, obviously we would have a lot more terms, but here we only needed the first two terms.